Any other questions?
I had some questions, however, I thought that it might take a little bit to like explain.
It's okay. Yeah.
Okay, so let's say you have a matrix C. However, it's non-square.
Yes.
And so I know that it's possible to get some, like most of the time it's possible to get something close to the identity matrix, but you're gonna end up with like a row of zeros. Or
Excuse me, I don't understand your question. So we start with a non-square matrix, correct?
yes.
What do we do next?
So let's say we row reduced it and got
We
as
apply
close
elementary row operations in order to do what?
to get as close as possible to the identity matrix.
Okay, okay. But it should be a non-square matrix, correct?
Yes.
All right, all right.
So what happens to the row in which, like, because it's non-square, you're
Yes,
going to you're not gonna have like the same amount of ones in.
exactly, exactly.
So what would the last row that would be
Yeah,
missing represent?
look. I think I know how to answer your question. Your question will be answered in section 3.7.
Okay.
Here's what I mean by that. Let us go back to section 3.5, and in section 3.5 we discussed, in particular, we discussed how to solve systems of equations. And I said, well, the goal of elementary row operations is to come up with a triangular form. But you can say, hey, for example, in this case, it's not really triangular form.
Yes.
It's who knows what. And here, it's not really triangular form. It's who knows what, correct?
Yeah.
So let us generalize. In section 3.7, we discuss so-called echelon form. Here's what I mean by echelon form. Please take a look at this. We have three types of symbols here. 0 means 0.
Yeah.
By black square, we mean any non-zero number.
Yep.
By asterisk, we mean any number, either 0 or non-zero. This is one of the goals of elementary row operations, to come up with so-called echelon form. Echelon form means echelon form satisfies the following property. Next square is necessarily to the right from the previous black square.
Yeah.
Number two, below and to the left from each black square, we have necessarily zeros. For example, going back to this, observe that this is not an echelon form. We have black square, black square, black square. We have two black squares in one column. This is not allowed. This is echelon form. This is echelon form. Similarly, what is written here is an echelon form. What is written here is an echelon form. Because we have two black squares, the next black square is to the right from the previous black square, and to the left and beneath, we have only zeros. So this is the goal, echelon form.
Yeah. So
if you excuse me, now, along with the echelon form, we have so-called a reduced echelon form. Reduced echelon form means the following. Number one, instead of black squares, we necessarily have ones. Difference number two, not only to the left and beneath, but above each pivot 1, we have zeros.
Yeah.
Used echelon form is probably what you meant.
Yeah.
Mhm.
So
For
once
example, excuse me, let me give
Sure.
you an example. Here is a non-square matrix. Here is a reduced echelon form. This is as close to identity matrix as we can get.
Yeah. So let's say you get to reduce the echelon form.
Yes.
What does it necessarily mean when you have, like, for this example, you have like,
Question is why here, correct? Well,
yeah,
let's go back to this example. So observe that we already have here echelon form. This is already an echelon form, right?
Yeah.
But for some reason, we keep going, and what we see in front of us here is so-called a reduced echelon form.
Yeah.
Why sometimes we need echelon form, sometimes we need a reduced echelon form. First, let me go back to this example. In order to solve this system, step one, we came up with the augmented matrix, and then we applied elementary row operations in order to obtain echelon form. Then we switched to the corresponding system, and in order to find the solution, we solved this system.
Yeah.
However, if we keep going and apply elementary row operations in order to obtain a reduced echelon form here, means 1, 1, 1, zeros, zeros, then the last column will be 3, 7, excuse me, 2, 7, 3.
Yeah.
Reduced echelon form gives us the solution either immediately or, like here, almost immediately. We switched from reduced echelon form to the corresponding system, and then all we need is to move the z terms to the right. Done.
Okay.
Does this make sense?
Yeah.